Hello and welcome to a quick tutorial on how to calculate EOQ and annual costs. This problem that I've created is very similar to what you'll see in your textbook. I apologize for background noise, but I've got my two birds who are deciding that they want to stay up a little bit and play around while I'm doing this. So apologize for the background noise. So economic order quantity basically is the most economic quantity to order per order to enable us to have the least total cost. And this takes into consideration material costs, ordering costs, and holding costs. In this example, you're going to calculate EOQ, and then you're going to calculate the actual annual costs, which EOQ is an important part of. And I'll go through this in each step of the way. So the first thing we have is the equation for EOQ. And I know that I provide a very nice graphic in the announcements, but for those of you who like math scripts, this is basically what it is. The square root of, whoops, this is all the numbers in it. Apologies. Let me give you the actual equation first. Apologies. I'll talk through these numbers in a minute. So it's square root of 2 times the annual usage rate, which is U, the ordering cost, which is O, cost per unit, and then it's divided by the holding cost, which is H, and then C would be, actually, we want the holding costs here. Sorry, so we want the holding costs. This is a bit of a typo. So basically what this is, H is the holding cost, and then you also want to multiply it by the frequency that the holding cost is applied in that year. So for instance, if you're doing a yearly calculation and your holding cost is presented as a monthly fee, then you would add 12 down there. Okay, if it's every 6 months, you'd use a 2. So you multiply your holding cost by 2. So in this example, we have 2 times. So let me go ahead. Sorry, I don't want to get too ahead of myself. So let's look at the information that we require. If I was to break out the annual usage rate, the annual usage rate is very simple. How many of these items do we sell per year? That's 10,000 units. Very simple. Ordering cost is the amount of each order. And that's very simple as well. So we use that as $500. So it's right up here. So it's 500. Each order place costs $500. Now, in the real world, your usage rate obviously fluctuates, and your ordering cost can also vary. There's a lot of variables. But for this model, we're going to assume that everything is fixed. If it is not fixed, there's other calculations that we could use to factor in the variability within that. You could either do it on a smaller basis where you can calculate the variability much easier, or you can just do or you can just do it in an average like this. Ideally, in the real world, you would probably calculate it on a per item basis. There's all kinds of ERP systems, and there's all kinds of equations you can find online that goes into detail. And during this class later on, we will go through some of these systems, and I will provide information on that. So, but for now, so that we can understand how all of these variables play around, we're going to go ahead with these assumptions that all the costs are fixed per year. Now, C is the cost per unit. And for cost per unit, we have $35 per unit, which is right here, prices paid. Now, when we talk about cost per unit, the cost per unit can be different between entities within the supply chain. Like for instance, the manufacturer may have a material cost plus the factored in fixed cost plus a variable cost per unit. So the manufacturer's cost can be very complex. When we deal about costs for like a distributor or a retailer, we factor in how much it costs to purchase the item from the manufacturer. So when we do that, we don't need to worry about the material cost to make the item. All we really care about is how much does that manufacturer charge us for the item, because it's going to assume that those costs are already baked into the pie, so to speak. Very important that each entity views costs differently. A lot of students get tripped up on that, so just keep that in mind, please. So now we also, so the holding costs per year, I'm just going to put that in here. Holding costs we have here is $5 per unit per year. So we're just going to say $5 per unit per year. Okay. And the factor is it's a yearly cost. So we just multiply it by 1 since it's yearly cost. Once again, if this was done every 6 months, we would multiply that by 2 to get the yearly cost. We basically want to make sure that the holding cost in the bottom represents a yearly cost. Simple enough. So yeah, sorry, I have the sniffle, so I apologize. You may hear me sniffing every once in a while. I'll try to keep that down. So when we plug everything in, we go to the square root of 2 times our annual usage rate, which is 10,000, our ordering cost, which is 500. Now all of this is divided by our holding cost, which is 5, and it's multiplied by the frequency, and it's once a year. Okay, once again, 6 months, twice a year, et cetera, et cetera. And the value that we get, I went ahead and punched this into my calculator earlier to save us some time. And we get the number of 1414.21. Now, order quantity, we don't order parts of an order, okay? You don't order like half of a pair of socks online. I guess you could, but it's pretty awkward. We order full orders. So you always want to round up to the next larger unit. So in this instance, we're going to use 1,415 orders that we're going to place in that year. True, the second order is going to have less than a full order. We can't help that. But the order, once again, the order cost is fixed. So if we order one item, it's going to cost us $500. And if we order 1,000 items, it's going to cost $500. Once again, in the real world, those costs may be variable, but for now, we're just going to apply it all to every order, no matter how big the order is. Okay, so now let me move this up. This is our EOQ. This is important. Now, this is going to be used to calculate our total annual costs. Let me get another slide in here. Insert new slide. So here, I have my text box here. So for total annual costs, we want to look at annual material costs plus annual ordering costs plus annual holding costs. So these are the 3 items that we want to calculate. So, sorry. The first one deals with how much the materials cost. What is the cost of the actual goods themselves? That's the material cost. Once again, if you're the supplier, this is actual raw materials plus whatever fixed and variable expenses it costs to make it into your widget, this example. The ordering costs is the cost for you as a distributor or as a retailer to order these items. So the manufacturer charges you this much to ship the item. Obviously, the manufacturer would not have an ordering cost unless there's an ordering cost for ordering the raw goods. In which case, if you're the manufacturer, you would use the order cost for purchasing the raw goods to make your item. And annual holding costs. This is how much it costs to hold an item in inventory while it's waiting to be sold. Once again, manufacturers, a holding cost would be the cost to hold raw materials, perhaps. And in the real world, obviously, this is very variable. Like, for instance, you may have a fixed warehouse cost, or we have a giant warehouse that costs $100,000 a year, and you would factor that across all the inventory based on how long it's inside the inventory. For example, that's just one way you can do it. But the annual holding cost basically is the cost for holding materials in a warehouse. And once again, we have a holding cost of $5 per unit per year. Tell you what, let me just add that box in here one more time, since that might make it easier. So I'm going to let me just add this real quick. I want to make sure we have this. And holding costs. Holding cost is $5 per year. $5 per unit. Year. Soon as I learn how to spell. So here's our data from the previous page. To calculate annual material costs, we want to use the annual demand multiplied by the material costs. So now the annual demand, another assumption is that we sell 10,000 units per year, obviously, and that these units are sold at a constant demand rate. Basically, we start selling 10,000 units. Well, we start selling at a certain rate at the beginning of the year, and we go to zero by December. And this is where economic order quantity comes in. The way the economic order quantity comes in, it basically tells us that we are going to purchase materials such that we will always have a certain level of goods to order. So in this case, we have, let me just add EOQ to this as well, just so you have it. I have a video that's on this. If you have any questions, let me know. So in this example, cancel. Control V. Okay, sorry. In this example, we have 1,000. Let me make sure it's correct. Yeah, so we have 1,414.21 or 1,415 because you can't order part of a unit. So we have 1,415 units. Okay, per order. So basically what this means is we're going to start with 1,415 units, and we're going to sell them down at a constant rate until we hit zero. Then we're going to purchase more to 1,415. Now, once again, in the real world, there's an assumption here that lead time is zero. So right here, lead time from the distributor, actually from this, from the distributor to the retailer is zero. This is important. In the real world, there's a lead time. And in a week or two, we're going to talk about how to factor lead time into this calculation. But for now, we're just going to assume that it's a zigzag. As let me see if I can draw this real quick. Just a quick sloppy drawing here. So basically, what we do, we start off with 1,415, and we go down until we hit zero. And then we'll say that's zero. Then we purchase a whole bunch, come back up to 1,415. We go down, and then go down zero, 1,415. Okay, it's very sloppy, but I hope this makes sense. Now, what we'll do eventually is we're going to factor in a reorder point. And what the reorder point is when we hit a certain level, we want to place our order so that when it hits zero, the stuff is already on the way to replenish. Once again, that model will take into consideration constant lead time and constant demand and all these other things. We'll discuss this in more detail in the next couple of weeks. So let me go ahead and clear all my drawings, and we'll get back to that. So I hope this makes sense. So when we go annual demand, our annual demand is, annual material costs. Sorry about that. Annual material costs, we're looking at, oops, I already had it there. I'm sorry. I'm getting ahead of myself. So it is annual demand, which is 10,000 units times the material cost. So it's very simple. How many units we order per year by how much each unit costs. And that's basically 10,000 times 35 equals 350,000. Easy enough. Now, annual ordering costs. Now, this is a little tricky. It's not too bad. So basically what this is, let me move this up a little bit so we don't run out of space, is the annual demand divided by EOQ. So what we're doing, this calculates how many orders we're going to place in the year. If we're going to be selling 10,000 units, we divide it by the number of units per order to determine how many orders. And once again, you round up, okay? As you see here, we go 10,000 divided by 1,415, okay? So, and we multiply this number by the ordering cost per order. So we calculate how many orders, multiply it by the cost per order, that gives us the ordering cost. Simple enough. So what we have here, so 10,000 divided by 1,415 equals 7.067. Now, once again, we have to order, whoops, Control Z. We have to place full orders, okay, because it's a cost per order. So we round up to 8. Once again, that order is not going to be a full order, obviously, but we have to order it anyway. So now we multiply that 8 by 500, it gives us $4,000. That's our annual ordering costs. That's important. Now, annual holding costs. The cost to hold materials in storage before it is sold. Simple enough. We have average inventory. So average inventory is a bit tricky. In this model, we'll always have an economic order quantity of 1,415. We don't want all 10,000 units in the warehouse at the beginning of the year. We want to order it such that we have an optimum order number, then we go down to 0, then we order some new inventory, then we go down to 0, order inventory, go down to 0. So, oh yeah, by the way, another huge assumption is that the manufacturer is able to fulfill this rate at a constant time. In the real world, obviously, lead times fluctuate, capacity fluctuates. So, this is not a very good real world example, but this is good for learning though. This allows you to understand the factors involved. So the average inventory, we're going to calculate it by basically taking the maximum inventory in the warehouse at one time and dividing it by 2. Now, the reason why we do this is, let's say that you took a bunch of numbers and you went from the top, the number down to 0 by ones. So let's say 10. If you went 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. If you added up all those numbers and you average them out, the number will come out to half of the largest number. Now, if you have an even number, that'll work out great. If you have an odd number, it is off a little bit. But for this math, it works in this math here. So 1,415 divided by 2, gives us 707.5. So actually, in this math, it works out great because you're able to have half a unit. If you had to go up to round units, obviously, if you went 10 down to 0 and you halved it, you wouldn't have like 5 or a 6. It'd be 5.5. So we have this here. So this represents our average inventory in a year, and then we multiply it by our holding cost. So the 707.5 times 5. Now, once again, you can't have half of an item in storage. So you could run it up to 708. Now, you could also argue, well, this is an average. So in some months you have 707, some months you have 708. So the 707.5 would be okay to use. It would be accurate. But in some cases, you'll see people only want to use whole numbers for this. So in the problem that you do, if you use the factor or if you use the whole number, they're both correct. Okay. It is a little bit different. It just depends on the method of inventory that individual uses. So for this, I just rounded it up, but you can use 707.5 if you want. So now 708 times 5, and you multiply that out, it gives us 3,540. So total annual costs let me just go here, will be 350,000, which is here, which is your material cost, plus your ordering cost. So basically, it's the number of orders multiplied by the cost per order, which we have here. Okay. We took the 10,000 divided by our economic order quantity and multiply it by 500, of course, using 8 as a order quantity and not 7.067. And this is important. Make sure that you round up. Okay, always round up. Now, and then we also had to calculate the annual holding cost. And once again, like here, I use 708. In reality, I should probably use 707.5. But if you do either one of them, I'm okay with it. The total annual cost will be $357,540. And if you play with these numbers, like let's say if you change the EOQ to, in this example, let's say if you change the EOQ to 2,000 or 900, you'll actually see the annual costs fluctuate. I put an announcement in class about how these graphs work. Watch the announcement if you have any questions. I also have a YouTube video that talks about this as well. So this is the EOQ allows you to optimize the lowest cost possible based upon all these variables. So this is a quick example of EOQ and total annual costs using total material cost, annual material costs, annual ordering costs, and annual ordering costs, sorry, and annual holding costs. And you just do the calculations here. And then at the end, you get a total annual cost. If you have any questions, please feel free to post them in the class. And feel free, I've got several videos on EOQ and cost calculations from other classes that I've done. Now the problems that you'll see in my other videos will be a little bit different than what you're seeing here, but the theories are fundamentally the same. Let me know if you have any questions, and I look forward to seeing you in class. Thank you for your time.